Hello everybody. Welcome once again. It's loud to see you for the final Encode X Fuel Educate series, for the final event in the Encode X Fuel Educate series. After 2 amazing weeks and 5 previous events, today we are wrapping things up with Alex from Composability Labs, who is going to tell us something about building stateless DeFi applications. If you have any questions, feel free to pop them in the chat as usual or in the questions tab, and Alex will get to them later on. But for now, Alex, the stage is
yours. You can ask the same question.
So this presentation, and today I'll explain you how to build your applications with predicates on Fuel. So I explain a bit about myself and Spark. So I'm Alex, I'm a CTO in Composability Labs, and our flagman product is Spark. It's a decentralized order book and also perpetual exchange with using predicate technologies, and it's can be super fast because of Fuel. Also, as you know, Fuel AVM compatible, and you can connect your wallet from every single layer 2 and like control your finance on Spark using like MetaMask on Fuel. If you wanna try Spark, you can scan this QR code and like enjoy Spark right now. The next slide. What predicates is? So predicates, it's a stateless account abstraction, right? Predicate, it's a UTXO model. It's like, do you know Bitcoin base, like how it works? But in Fuel, it's exactly the same. You have like some hash, you send money to this hash, and you have some code of predicate, and this code just return true or false, and depends on like calculations on predicate. You will be allowed or not allowed to withdraw money from predicates. You can like feel analogy. It's kind of like a safe. You have a code to this safe and have something inside, and if your code is right, you can get money or something or NFT from this predicate and use it how you want. So let's go to examples. I prepared to you few projects like what you can implement using predicates on Fuel network. First of all, you can what you can build here. You can build conditional payments. It's kind of predicate can allow you to get money from predicate with some conditions. Here are using timestamp. For example, you creating a predicate hash, right? Like here. After that, you send money to this hash, and if you want to withdraw money from predicate, you need to achieve like conditions of predicates. Here, it's a block timestamp. After, you can build a multi-factor authentication. In configurable block, you just put signers, and in predicates, you need to verify if signatures is okay. And if it's okay, like you can withdraw money or what's locked on predicate. Also, there is example of escrow payments. Like what's escrow? It's for example, when one part wants to exchange money to another part, but another part needs to approve that money is received, and this money is locked on escrow payment predicate. And as soon as you have a seller and buyer signatures here, you can get money from this predicate. Let's go to another examples. Here I implemented a simple version of fundraising predicate. On this predicate, you just can collect money on this predicate, and you have fundraiser address, fundraiser asset, and goal amount. And as soon you achieve goal amount, you can withdraw from fundraiser address money. You can withdraw money to fundraiser address right here. Also, you can build like exchanges, everything you want. Like here, I created example of selling NFT. You can just make an NFT order book, NFT marketplace using this predicate. Here you in configurables defined NFT ID, price, seller, and payment asset. And as soon as all of checks done, you have a true and can get NFT and the money. So in predicates, we have inputs and outputs. What's input? Input, it's like when you call predicate, you attach some money, and this money attached here, it's your input, and you provide output. Outputs is for what place you need to get NFT right here, and here you just check all of conditions. I mean, something like this. Also, you can build something like gambling. Here's a simple example of lottery. You have a winner, lottery, asset, draw time, and seed. Seed, it's too random. Here you can use some pseudo-random on fuel network implementations. I did it just simple, not really random stuff, but you can make a gambling stuff here. And last page, I created a vesting predicate. What's vesting? It's like when you have some tokens, but you have to wait some time before you can claim it. And it's kind of the same as on first slot, but it's already kind of production version of vesting predicate. Also, my favorite, I implemented once a former game. How it works? First person deposit money, and the timer is resets. Like, and after 20 minutes nobody deposit more money, person gets all cash. And if second person deposits money, the timer resets, and you should to wait 20 minutes to have a possibility to withdraw all bank. And here you have this example of predicate. And also, last but not least, prediction market. Here I created a small example of prediction market. You can play with that. After this presentation, I'll show how to implement like simple predicate. You can play with that after. So, and here I want to explain you how we built a predicate-based order book on Fuel network. So the key features of this order book, it's like super fast. For example, just imagine you have an order book with a lot of markets just on one contract. For example, we have a lot of trades on Bitcoin markets and a small amount of trades on Pepe markets. But all of people gonna call every one contract, and it can be like overcrowded. First of all, what can we do? We can divide it to different contracts. For example, Bitcoin market, it's a one contract, and Pepe market, it's another contract. Okay, well, we have a parallelization, but Bitcoin market can be overcrowded as well. But using predicates, we are doing parallelization to every single order. For example, like one order, it's a one stateless predicate. And this system have a maximum of parallelization. And as soon as predicates are stateless and UTXO based, it's almost free. So we have a extra fast and almost free order book. And how we achieved that on Fuel network? Here you have a configurables. Configurables you set when you like creating a predicate. We have a quote asset and base asset. Let's say quote asset is a Bitcoin, base asset is USDC. Maker is the person who created a predicate. Price, it's a price of order. And treasury, it's I forgot to remove it. It's for fees. Okay, never mind. So here it's the main function, the function that understands like what do you want to do, and redirect you to function of your action. So you can fill buy order, fill sell order, or cancel order. If you're filling buy order, we have a simple math here. You have a checks like everything is okay with numbers, and maker is not zero. After that, you get quote and base asset from inputs and outputs, calculate the price and check if it's okay, and check outputs like base asset and maker. And for sell order, we have kind of the same math, but on a bit different way. And if you want to cancel order, you should to like call predicate from maker and like provide zero amount of some token. And here we detect like in inputs we have some zero amount, and also it's maker, and okay, why maker can call predicate just for cancel. It's also simple. And about I want to say about matching. You gonna ask, okay, it's cool, but how we can match these orders? You can kind of consume predicate and put as output address another predicate, and it can be like self-consumable predicates that exchange money with each other, and that's how matcher is works. For indexing predicates, we are using intents in our order book. So that's pretty it. You can follow Spark Twitter here or my Twitter right here. Do you have some questions before I start the workshop?
Yes, guys, let's give it maybe a couple of moments for people to type some questions if they have some. I see Adam is typing something in the chat. Yeah, the question says, you said that predicates support custom conditions. Could this be, for example, the stop loss orders for traders?
Stop loss orders. You can provide custom conditions. You can send it to main function, like I sent here an action, and like use it in computation inside the predicate. Also, when you're creating a predicate, you can provide some configurables that gonna change like predicate root. It's manageable.
Cool. Please let us know in the chat, Adam, if this answers your questions. But let's move to the. Okay. Looks like it does. There's a question. A question step as well from Simeon. Sorry for butchering your name. What are the advantages of using predicates and fuel instead of other ecosystems?
Instead of other ecosystems, it's cheap and parallelizable here, and actually I know like we are also using predicates, kind of predicates on Polygon Maiden. It's a zk-VM. It's kind of the same, also free, also almost free and super fast. But the key benefits of predicates, it's first of all security, because you have a decentralized liquidity, like for example, in smart contract, you have all of liquidity in one place. But in predicates, you have all of liquidity in small stateless like predicates, and it's way much harder to like exploit it. Also, flexibility, you can support custom conditions, cost efficiency, and also it's really fast because of parallelizations.
Amazing, thank you. Any other questions before we move on? Yes, there's one from Cable. What's predicate storage? Is it all off-chain?
There is no predicate storage because it's a stateless. Or what do you mean about storage? Like where it's stored, like predicate itself? So when you create predicate, you just have a code, make configurables, and create a hash. It's like just calculations. It's not like a sync function. And after that, like you have a kind of slot in blockchain where you can send money, and you just send money to predicate root, and it's already charged. After, if you want to consume predicate, you get predicate and call it like by SDK to consume it. Put inputs and outputs, and how to handle inputs and outputs you can find here.
Awesome. Looks like there are no more questions at the moment, so I think let's move on with the actual workshop.
Okay, sweet. So now I'll explain you how to create own predicate. So first of all, we're gonna install fork, and after that you can type fork new predicate test, for example. Oops. Let's try again. Yes, that's it. I'll go to predicate test. And what we have here, we have a fork toml with project details. Also, you can use some libraries here, and src file with -v. Here, we can inspire by some of our predicates. For example, let's start with simple one, this one. Here in Fuel, we have 4 types of contract types. First of all, it's contract. After it's predicate, also script and library. If contract, okay, you understand what is it. And library, you can use it like in contracts. Okay. Predicate, it's already explained, and the script can call like in one transaction few actions. For example, script can charge predicates, send money to predicate. After that, call some contract and read some data, make some calculations, and depends on calculations, make something else. And today we're gonna use a predicate type. Sweet. And we don't need any AB, and it's just a simple main function. That's it. After you here, you can put your logic. As soon as you finish this, you can build your predicate. As logic, you can put like every predicate that we have here, like, and test it. So that's it. We have a predicate root. We just build it and have a predicate root. After that, we can make some tests. For creating test environment, you can use cargo generate command. All of these commands you can find on Fuel documentation. I forgot to tell you, after building of predicate, we have like artifacts of building predicate. It's a ABI, JSON file. Also, you have a predicate root right here and have a binary file of predicate. With these files, you can start to testing it. It's, I don't know why they have only examples for contracts, but let's do it as a predicates. Here you can put your JSON file, this one. And also here you need to use keyword predicate. And so here you initialize the wallet, and here you have an order book ID. But let's do it predicate way. Some bytes doesn't help me. As you have example here, we can use it like this. And configurables. Maybe like this. So here we have a predicate, and as soon we have a predicate, we can let me change it. You have a predicate root inside the predicate. It's an address of predicate. So, and here you have a wallet. I need to get one from here. Wallet. Transfer to predicate root. Amount 1 asset ID. I'm not sure what asset ID we are using here. Let's do base asset ID. So, and this way you can charge a predicate like to do it. That's it. And predicate charged. And how uncharge it? To be honest, I forgot. So that's pretty it. I'm sorry, guys. I forced to check it in my code. Like this. So you're creating a script called handler. Somehow you provide to some bytes. Provider. Let's copy all of this. So here you have a provider. You get it from wallet. After that, you get a predicate clone. After that, you install provider from wallet to a predicate. Also, you, as I showed in presentation, you have inputs and outputs like here. You configuring your inputs and outputs to predicate. And after that, you preparing a script call and sending to here like predicate. It already have a in provider predicate root. That's pretty it. And this way you can call a predicate. I don't know why unresolved byte bytes doesn't work here. So anyway. I think I'll finish it a bit, maybe add some example from here, and I'll make it public. Do you have questions?
Yeah, if you have any questions, guys, feel free to pop it in the chat. There's one from Caleb for escrow predicate. Can we make a partial withdrawal without risking a replay tag?
Yeah, that's an interesting question. When you want to make a partial withdrawal, can I go to my order book code. Here we have also partial withdrawal functionality, and when you make so it's UTXO, when it's fulfilled, it's like removed, it's like burned. But what you can do, you have a predicate root, right? And when you have outputs, you know, like the rest of money like still on predicate, and just you need to make output to same predicate root, and that's how you can like recharge predicate after partial withdrawal, and it can be ready to make one more withdrawal. And I'm not sure, but seems like it's already inside the library. So here it's a change output type. And if it's 0, that means like everything that keep still on predicate like gonna be recharged. So it's automatically included on SDK, but now you know how it works. So it's possible.
Perfect. Ibuka is asking, please, can you show us where the predicate root is?
Predicate root. As soon as when you compile predicate, you have a out file, and you have a predicate root file here, and you can copy it. After when you're building predicate, you have a predicate root like printed here on your console. Look, it's the same. And when you make a test, let me comment this. You have a predicate root. And it's also the same. You have 3 ways to get to predicate root: using SDK, using like debug files, and during the compilation.
Cool. Any other questions? Till we wait for more questions, Alex, maybe if you can share this code with the audience, if you have already a repository which you can share or a link, that would be amazing.
Our predicate-based order book, it's open source. You can find it on our Compo Labs repo, like it's a SparkRS repo. And this one, I'll finish a bit, add here one of examples, and create a small test, like to show you like full power of predicates.
Amazing. All right. Looks like, okay, somebody's typing. It looks like we have another question coming in. Don't be shy, people. If anybody wants to know anything, this is the perfect time to ask. Yeah, Ibuka says we really appreciate the public repo when you are done. Cool. No worries. We'll make sure to pass that along with the video recording of the event. Can you speak about what predicates may do or be like moving forward into the future? Like, what's the future of predicates? What's the future of predicates? Yeah.
So I think it's good to on-chain order book. That's why we're building on-chain order book on predicates. I think like it's the coolest like using of predicates. Also, predicates can allow you to make a lot of simple on-chain like activities without any contracts, without any deployments of contracts. You need just open your IDE, make a small predicate, make a predicate root, and that's it. Also, like I like the way of SDKs. For example, you build predicate, and you want to like everybody can use it. How we do it on our end? We're creating a SRC folder inside here and adding here utils. It's like wrappers on predicate calls, and push it on GitHub. And everybody who wants to reuse it, just open cargo toml, put here something like this, and can reuse your SDK with your predicate, even with your code. Predicate binaries already here. You can easily like, you don't even need to build something. Like it's pretty fast to integrate it with some project. I think like it's a future. of Ethereum ecosystem. I hope so.
Cool. Any final questions before we wrap it up? What would you recommend developers should use more predicates? Would you recommend developers should use more predicates than contracts?
I would recommend to understand your target, what you're doing, and you choosing technologies depends on your project, not project depends on technologies. Like if you want to build something and predicate can give you possibility to achieve some goals, like to decrease costs or increase speeds, why not? You should use predicates if it can help you. But if you use predicates just because of you want to use predicates, it's not the best idea, to be honest.
Yeah, a very sound and wise piece of advice. Okay, looks like there are no more questions this time. So, Alex, any final words of wisdom for the audience before we wrap it up?
Yeah, as soon as I finish this wonderful predicate, I'll push it to my Twitter account, and also I think SparkFi gonna retweet it. So let's keep in touch. Follow my Twitter, follow SparkFi Twitter. Also, we have some announcements soon that my legal part of team asked me don't give it to you today.
That's perfectly fine. Thank you very much for giving us a heads up nonetheless.
Yes.
Okay, then I think we slowly wrap it up, guys. This has been an amazing 2 weeks. This is session number 6 and the final session in the series. So thank you very much to Alex for coming in and doing the workshop and the presentation. Thanks to everybody else for coming in for the past 6 sessions. They've been, I think, amazing piece of content and amazing bits of learning about not just Fuel, but predicates and Web3 in general. So very soon we will be launching the Encode X Fuel Hackathon. We don't have an exact date yet because it's actually being pushed back a little bit from what it says on the website, but it'll be starting sometimes towards the end of August. Until then, have a lovely rest of your day, and yeah, see you around. We'll be in touch on Discord and the other socials. Thanks, everybody. Have a lovely evening. Bye-bye.
Thank you, guys. Bye-bye.